Okay, good afternoon again. So let me share my screen again. কি হ'ল তেতিয়া বেছি ষ্টুডেণ্ট আছিলে এতিয়া আৰু কমি গ'ল যে 100জন ষ্টুডেণ্ট কমি গ'ল Okay, so selection sort clear to everyone. So next sorting algorithm is your insertion sort. Okay, first you guys tell me, in last class we did programming for linear search or not? Have you done programs for searching linear and binary search? Yeah, কি programming কৰিছো আৰু মনত নাই নি anyone? What are the programs we did in last class or I showed? Anyone? It did string functions, correct? Yes, correct. Last class means in last lab class we did strings. After that we had Eid holidays, so no lab class. Okay, I'll show this selection sort algorithm first. After that, I'll show the programs for linear and binary search, okay? Okay, next sorting algorithm is, I'm going a bit fast because your exam will start from July. So we still need to cover a portion. We can finish the syllabus easily, not a problem, but it's fine. If you are taking that I'm going too fast, then you can tell I will stop here. Then we can just go to the program of linear and binary search. So let me just know, you want to go for the next sorting algorithm or go for the linear and binary search program? It's fine, we can go for the both. So next algorithm is insertion sort. So asking you guys again if you have any confusion in selection sort. Any confusion in selection sort? If yes, just let me know. If you do not respond, I will not know. Respond something. No confusion, Shreya. Can you explain it in brief once? Okay. Okay, so in selection sort, what you have to do? Find the minimum element first. Could not attend class. Back to button. Okay. Okay. So selection sort means select the minimum element. Just see the name and try to find what it is going to do. Is the better way to remember what algorithms, what type of sorting algorithm is for what. Selection means select the minimum element, then you place the minimum element in the first position and swap the value. For example, here 12 is in first position and you just consider the first element as like half part is sorted and rest is unsorted. So in the whole array, you are going to find the minimum element first. Then you will place that minimum value in the first position. So you will simply swap the value or swap the position. Okay, here 7 is the minimum. You will just swap with 12. So 12 will come here and 7 will come here. Okay, so 1 is done. In second position, now you move to the second value. Now second value is 10. Okay. Now again do the same thing. You find which one is the minimum value. Now again in this part of unsorted array 9 is the minimum value. So you will swap the value of 10 and 9. Why? Because this is the place for the second minimum value. So you will place 9 here. So 7 and 9 is sorted. Next, you move your index again. Now it is in the third place, which is 16. Now again, you do the same process. Find the minimum element from the unsorted part. 10 is the minimum. So you again swap the value of 10 and 16. Now you move again. You are in 11 now. Now again do the same thing, but now you found that 11 is the minimum value itself. So no need to swapping anything. So it's just sorted. So you next move to this element, which is 16. Now again 12 is the smallest element. So you will swap the value. So finally this is your swap value. So selection sort means select the minimum value and place it in the correct position. And this is basically like opposite of your bubble sort. In bubble sort, you find the maximum value, means at the end of first pass, maximum value placed in the correct position. Okay, and in selection sort, after first part, this first pass, smallest element comes to its the rightful position. Okay, so next is the insertion sort. Insertion sort, you can just think about your cards. If you have ever played card games, then suppose I am just giving you a deck of cards and I am asking you to arrange the card in 1, 2, 3, 4, 5 in a manner, in numbers. Okay, so what you are going to do? You will simply find one card first, then you will place in the first position, correct? Then you again find the second card and put in its correct sequence. So that way you just arrange all the cards in your hand. Now I don't know if we do it in different ways, but that's the basic way of sorting your cards. Have you ever played with cards? So if you don't know the cards, that means what? You have to go through each card for the starting, or you will just try it from the back side. Okay, whatever you do, if I give you an unsorted deck of cards, you have to go through each and every card, then find the correct card and place it in the correct position. You just insert the correct card in the right position. So same concept is used in case of selections, insertion sort as well. So what happens here? It's again the comparison based sorting algorithm, and a sublist is maintained here for all sorted items. Okay. So an element which you need to insert in the sorted subarray has to find its appropriate place, and then it has to be inserted there. So name is the insertion sort. Okay, so I guess just let's go for the example. It will be easier to understand. Suppose you have an array twenty-three, 1, 10, 5, and 2. This is your array. So what you do first, suppose you consider the first element as the sorted element. Okay, you first check first to one. This is your first pass. So compare 23 and 1 now. Which one is the smallest one? Suppose your index is here 23 and you think 23 is the correct place. Okay, correct item. So you just consider first item to be the sorted element. Okay, 23, 1, 10, 5 and 2. You just think that first one is your correct. Okay, now your pointer move to the second element, which is 2. Okay, 23, 1. Okay, now you will see that 1 is smaller than 23. Okay, 1 is smaller than 23. That means what? You need to swap the value. What? It's not like exactly swapping. You are going to push the value that side. That means what? You will put your 1 here and push 23 backwards, then rest of the element will remain same. Okay, that means you are going to place 1 in front of 23 and you will just push the rest of the values to the right side. Okay, now this one is done. Suppose this part is just sorted part. Okay, now your element is at third value, that is 10. Again, now again you compare this 10 with first 23. So is it smaller or greater than 23? It is smaller than 23, correct? Then again it is greater than 1. So correct position of 10 will be 10. You just push 23 a bit here. Sorry. 5 and 2. Done. This is your third pass. Okay, now this part is sorted. Now your index is at this place. Okay, again same process. You will compare 5 with 23 plus. The intermediate will be, that means it should come here. Next you again compare that 5 with 10. Again, it is smaller than 10. Therefore, your 5 should come at this position. That means you will just shift this part here. 1, 5 will come here, 10 will come here, 23 and 2. Okay. Next, your index is at last position, that means value. Now you compare 2 with 23 plus, it is greater, 23 is greater than 2, that means this is not the correct position. Then you compare 2 with 10, again it's smaller. Then you compare with 5, again it's smaller. So correct position of 2 should be at, compare with 1, it's greater, that means it should come here. So after this it will come 1, 2, 5, 10 and 23. So this is your sorted array. Okay. Clear? Just see for a while. First element is 23 and you just consider first element is sorted array. Okay. So you move to the next element, which is 1. Okay. Now you will compare this one with 23. Now 1 is smaller than 23, so its rightful position is at the first place, correct? So you will just shift other values to the right side and place 1 here. You are not swapping the values. Okay, just notice it, just observe it. You are not swapping the values, you are shifting the values. So 1 will come here, 23 come here. So now I am thinking this part is sorted. Okay. Next, your index will move to the third position. That means third number is 10. Now again you will compare with 23 first. 10 is smaller than 23, right? It should come here. So intermediate will be like 10 will come here and 23 will come here. Then again you will compare 10 with 1. But 10 is greater than 1, so it is in the correct position. Correct? So no need to change. Next, your index will come here. Now number is 5. Now you will compare 5 with 23 first. 5 is less than 23. That means it should come at this position. Okay. Intermediately, it will just come here. Okay. Intermediate array will be like 10, 5, 23 and 2. Okay. Then you will again compare with 5 with 10. So again 5 is smaller, so its correct position is here. Correct position is here. So you will again shift it and come to this part. 1, 5, 10, 23 and 2. Okay. Next you come to the last part, 2. Now again same thing, you will compare 2 with 23, 2 is smaller. Then you compare 2 with 10, smaller. Compare 2 with 5, smaller. Check with 1 also, it's greater. So correct position of 2 is here. So you will directly keep it here and shift the rest part. Okay, that's how you insert it. Is it clear? Selection sort.
Yes, ma'am.
Okay, one person said yes. Good. So it will be stable or unstable, and adaptive or non-adaptive. Stable or unstable. Insertion sort is stable. It will keep the sequence as it is. Okay. And it is also adaptive. Why adaptive? If some of the parts are already arranged, it is not going to change it. Okay. So it maintains that. So time complexity is O(n) here. In the best case, if your sorting means it's already sorted, complexity will be n, but anyways, worst case complexity is O(n) squared, just like your selection sort. And space complexity is also O(1). So these are the three basic but very important sorting algorithms. These are comparison based and in place sorting algorithms. So bubble sort is stable and it is also adaptive. Then your selection sort is non-adaptive and unstable, and insertion sort is stable and adaptive. Okay. Okay, let me. Is it clear to everyone? Okay, good. Okay, so for lab part, your first task will be to write a program for the linear search. Linear search program is very easy, so I will not give you that program. I can show you the program for binary search. Okay. Okay, let me stop this one and share you the programs. Okay, can you see this one? So here in this program, there are different types of variables. So what's the main approach for binary search? We divide the array into two halves, right? The main concept is we divide the array into two halves. Then we see the midpoint. Okay, then we see whether the item you are looking for is greater than or equal to the midpoint. Okay, if it is greater than the midpoint, you select the right part, and if it is less than it, then you go for the left side. Okay, and the main criteria is the number should be in sorted array. So whenever you do binary search, just put the values in a sorted array. Okay, so there can be many programs available. This one is the simplest one. So what's happening here? You are just asking the user to set or enter number of elements. Then you just enter the values. So you just select which number you want to find. So main thing is coming here. So first you set first equal to 0. That means index for the first is 0. Then the last index is the n minus 1, right? If there are n number of values, obviously if you start from the index 0, the last index will be n minus 1. Then how you are going to find the middle value? Middle will be first plus last divided by 2. Okay, first plus last divided by 2. That's how you are going to find the minimum value. Okay, then now if first not equal to last, you will check. This is just the condition. Okay, here you haven't used the for loop, here you are just using the while. So up till when you are going to continue? Until first become the last. That means first index will become the last index, or you have searched in the whole array. Okay, so first you will check whether the middle value is less than searched item or not. So I'm keeping the search item as search itself. Okay, so you are checking whether the item at the middle is less than search or not. Okay, if yes, then first element you will set as middle plus 1. Okay, otherwise that means your if middle element is the search element, then you will just print you found the location. Okay, and you will just provide the location of that searching element. Okay, so if you already found that element and which is the middle element, you will just put a break. That means you are not going to check for the other conditions. Okay, then else means if middle is greater than search, you are going to take last equal to middle minus 1. Okay, okay, wait, I already have a PPT on that. Let me find that one. It will be easier for you guys to understand. I made it in last class. Let me find if I still have that PPT. Where are my PPT? Okay. I don't know where I keep that PPT. I'll just draw it here, okay? Yeah. Okay, suppose this is your array, same array, okay? Obviously, this is not the sorted one. Anyways, this is your sorted array. Okay, that I just draw it. Okay, so 0, 1, 2, 3, 4. There are 5 elements. So you are just considering this is as the first in the program, this is your last, and this is your middle. Okay, so you are searching for particular item. Okay, so now if your search item is greater than mid, okay, if search is greater than mid value, that means what? You are going to consider this part. So index for this one will be mid plus 1, correct? So you are going to only select this subpart. You are going to completely disregard this part. So in this subpart, your first will be set as mid plus 1, correct? And last is still your n minus 1. Okay. Now if your mid is search is less than mid, that means what? You are going to consider this part. You are going to consider this part, right? So in this case, for this part, index will be mid minus 1, correct? So for in this case, so this is the case here. So in this case, your first will be still 0 and your last will be mid minus 1. Clear? See in the program where you saw the search is greater than mid, that you have set first equal to mid plus 1 and last will remain n minus 1. Last is still there, this subpart. Okay, we are going to consider only this part if searching item is greater than your mid value. So if you search only in this subpart, so your first element will be your mid plus 1. Okay, this item is nothing but your whatever is the location of mid, that means it will start from 3. Okay, if your searching element is less than mid value, then you are going to consider this part, right? So this is nothing but mid minus 1. So location of mid 2, then mid minus 1, 2 minus 1 is 1. Okay, so first will remain same. Index will start from 0, but the last item you will consider as mid minus 1. Okay, clear? So let's go to the program again. Okay, so same thing. If it's less than, you are just putting that first equal to middle plus 1. And in the other case, you are putting mid minus 1. Okay, that means here searching item is less than mid item. So if you run the program asking for number of elements, let's say 5, items 2, 4, 5, 7, 8. Okay, enter the value. Let's find 8. So it's showing 8 is found at location 5. Okay, so it's just done here. Got it? So I'll share the program with you guys, but your part is to write a program to find the linear search. Okay, I'll share this program with you guys. So you just check it a bit. Okay, I'll stop sharing because meeting is going to finish. Switch on your videos for a while. Switch on your videos.
Ma'am, more loading দেখাইছে on হোৱা নাই
কি হোৱা নাই?
ঘূৰিয়ে আছে অথনি পৰা এতিয়ালৈকে ভিডিঅ'টো অন হোৱা নাই
ভিডিঅ'টো অন হোৱা নাই। বুজি পাইছা চবে? Sorting, 3টা টাইপৰ sorting বুজিছা? Binary search program to বুজিছা? I'll share the program with you guys. এবাৰ চাবা, বুজি পাবা ইণ্ডেক্সটো কেনেকৈ লৈছে। Okay, but your part is to
Okay.
find the program or write the program for linear search. So once you get it, just give the screenshots in the group. বাকীবোৰ কি হ'ল? Someone just said it now. Clear নে চবৰে? If you don't respond, I won't get it. লাষ্টত নকবা মেম এইটো বুজি পোৱা নাছিলো সেইকাৰণে নোৱাৰিলো। I'm asking you guys over and over again. If you don't understand, just respond. Okay, Jiasa said yes. So she is just here, so I can see she's just telling from everyone's side. Okay, thank you. Video, well, important. Yeah, I shared all the videos in the portal already. Okay, I'm ending the meeting right now. Thank you all. See you tomorrow.